Welcome to the lecture number 6 of Theory of Computation. So in this lecture we will go through what exactly a Mealy machine is, then we will go through Moore machine, then we will go through conversion from Mealy to Moore machine, then we will go through conversion from Moore to Mealy machine. Right? So what exactly a Mealy machine is? An automation is said to be a Mealy machine if its output depends on the present state as well as current input. So you see, up to now, what we have studied, we haven't considered the output. We have only considered given a state, by taking one input it goes to which state. Okay, so given a state it takes an input, it goes to the next state, but we haven't concentrated on the output. So in today's lecture we will concentrate on the output part also. So there are basically two kinds of machine. One is Mealy machine, another one is Moore machine, which produces some output. So in Mealy machine, what it will do, it takes the present state and current input as the input, then it determines the output. So in our real life, most of the examples are Mealy machine. For example, your chocolate vending machine, automatic washing machine. So here it is from a state, it takes some input, then it goes to the next state as well as it produces some output. So a Mealy machine can be mathematically defined through a six tuple. So it consists of finite non-empty set of states, finite non-empty set of input alphabets, an output alphabet. This symbol is denoted as tau, then the transition function which maps from a state q and it takes an input alphabet and it moves to the next state. This is similar to finite automation. Okay, so then another one is output function. So as in Mealy machine, the output depends on the present state and current input. A state, by taking an input, it produces some output. So the output is dependent on both present state as well as current input, and Q0 is the initial state. So similar to Mealy machine, Moore machine is an automation in which the output only depends on the present state only. So in case of Mealy machine, the output depends on both present state and current input, whereas in case of Moore machine, the output depends only on the present state. So mathematically, a Moore machine can be also defined as a six tuple. So the six tuple are similar to Mealy machine, except there is only one difference. Here you see, in case of Mealy machine, the output depends on the present state and current input. So the output alphabet function is q to input alphabet to the output alphabet. But here, in case if you see in Moore machine, the output only depends on the present state. So example of Moore machine are, I hope all of you have gone through a supermarket, and in the supermarket you have gone through the accelerator. So in accelerator, what you will do, it continuously moves either towards the upward or it moves towards the downward. In one accelerator you move upward from one stair to another stair, whereas in another accelerator you are moving from upstair to downstair. So here, whether a person stands on the accelerator or not, the accelerator continuously moves from one state to another state and it rotates. Okay, so the next state or the output is only dependent on the present state. So I hope all of you have understood the example of Moore machine. So now let us go through how can we convert a Mealy machine to an equivalent Moore machine. So here I have drawn a transition table. So this transition table represents a Mealy machine. So here you can clearly see that here the output depends on the present state as well as current input. Okay, but in case of Moore machine, the output is only dependent on the present state. It doesn't depend on the current input. Okay, so here you see how while converting a Mealy machine into its equivalent Moore machine, what we will do, first we will check what are the outputs associated with the next state. So here you see Q1, here it is associated with 1. So Q1, where you are having a Q1? Yes, here you are having a Q1. So Q1 producing output 1. So Q1 always produces the output 1. Now let us go through Q2. So here you see Q2 producing output 1. But here you see Q2 producing output 0. So Q2 sometimes produces output 0, sometimes produces output as 1. Next Q3 Here you see Q3 producing output as 0. Here you see Q3 producing output as 0. So Q3 always produces output as 0. Now let us go for Q4. So here you see Q4 producing output as 1. Here you see Q4 producing output as 0. So Q4 sometimes produces output 0 and sometimes produces output 1. So now if a state produces different outputs while converting that Mealy machine into a More machine, what we will do? We will split that state into number of outputs it produces. So Q2 produces two outputs, Q0, Q1. So we will split Q2 into two states. One is Q2 0 means Q2 producing output as 0 and Q2 1. Q2 1 means Q2 producing output as 1. Similarly for Q4, here you see Q4 producing output as 0, Q4 0 and Q4 producing output as 1, Q4 1. So Q1 is producing only one output, always Q1, so we will not split Q1. Similarly Q3 always produces output 0, we will not split Q3. Whereas we have splitted Q2 and Q4, right? So by doing this, we can convert a Mealy machine to its equivalent More machine. So let me write the More machine over here, More machine. So the More machine, so now here you see the More machine. So here let me take the present state, present state, present state. Now here let me write the next state, next state. So next state will be dependent on the output, will be dependent on the present state and current input. So A equal to 0, A equal to 1. Whereas in case of More machine, the output only depends on the present state. So here let me write output, output, right? So now here you see I will start from Q1. So Q1 will remain as the initial state as it was the initial state in Mealy machine. So Q1 by taking 0 as input, what is the next state? Q3. So you will write Q3 over here. Q1 by taking 0 as in 1 as input, what is the next state? Q2. What do you see? We have splitted Q2 into two states. One is Q2 0, another one is Q2 1. So here what we will write? Q2 0 or Q2 1. Let me see the output. So Q2 producing 0 as output. So here I will write Q2 0. So what is the output? Q1 always produces 1. So I have written 1. Now let me go through Q2 0. So Q2 I have split it into two states, Q2 0 and Q2 1. So Q2 0 by taking A as 0 as input. What is the next state? It's Q1. So I have written Q1. Next, Q2 0 by taking 1 as input. What is the next state? Q4. But I have splitted Q4 into two states, Q4 0 and Q4 1. So whether I will write Q4 0 or Q4 1. Here you see Q4 produces output 0. So here I will write Q4 0. Now Q2 0 produces output as 0. Similarly Q2 1 produces output as 1. So Q2 1, what is the next step for A equal to 0? It's nothing but Q1. And what is the output for A equal to 1? It will be remain as it is, Q4 0. So let me draw a line. Okay. Next Q3. So Q3 by taking 0 as input, what is the next state? It's Q2. So Q2 producing 1. So here I will write Q2 1. Okay. So Q3 by taking 1 as input, what is the next state? It's Q1. So Q1 is only one state. So I have directly written Q1. So Q3 always produces output as 0. So here what I will write? I will write 0. Now let us go for Q4. So Q4 we have split it into two states. One is Q4 0, another one is Q4 1. So let me write Q4 0 and Q4 1. Right? So Q4 0 by taking A equal to 0 or input equal to 0. What is the next state? Q4 producing 1. So Q4 producing 1 means Q4 1. Now Q4 by taking 1 as input, what is the next state? Q3. So Q3 there is a single state, we haven't splitted it, so I will directly write Q3. So Q4 0, what will be the output? Q4 producing 0 as output. So Q4 0, the output is 0. Now let me go for Q4 1. So Q4 1 is nothing but Q4 producing 1 as output. So I have written 1 as output. So now Q4 1 by taking 0 as input, what is the next state? It's Q4 producing 1 as output. It's Q4 1, right? So Q4 by taking 1 as input, what is the next state? It's Q3. So now here you see I have converted this Mealy machine to its equivalent Moore machine. Okay. So here you see the output doesn't depend on the current input. It only depends on the present state. So let me go through another one, that is conversion from Moore to Mealy machine. Okay. So conversion of Mealy to Moore machine is a bit tricky, whereas conversion from Moore to Mealy machine is dead easy. Okay, so here you see the output does only depends on the present state. It doesn't depend on the current input. But while converting this Moore machine into its equivalent Mealy machine, what I will do, I will draw the present state. So present state, and here I will write. Okay, let me view the previous example. Next state. Okay, next state. So next state. So in next state, I will have A equal to 0, and here output, and here A equal to 1, and I will write output. Right? Or here this is next state A equal to 0, next state A equal to 1, output. So present state, what was the present state? Initially I will take the initial state Q0, right? So Q0 will remain as the initial state. So Q0 by taking 0 as input, what is the next state? It's Q3. So Q0 produces which output? It's 0. So here I will write 0. So Q0 by taking 1 as input, what is the next state? It's Q1. So here I will write Q1. Q0, what is the output for Q0? It's 0. So I will write 0 first. So now Q1. So Q1 by taking 0 as input, what is the next state? Q1. I will write it over here, Q1. Q1 by taking 1 as input, what is the next state? It's Q2. Now I will write the output. So if there is a state Q1, what is the output? It's always 1. So for A equal to 0, it will produce 1. For A equal to 1, it will produce 1. Next, let me go through Q2. Q2 by taking 0 as input, what is the next state? The next state is Q2. So the next state is Q2, right? So here Q2 by taking 1 as input, what is the next state? Here I will write Q3. Now output, Q2 by taking both the 0 and 1 as input, what is the output? Output is always 0. So for input A equal to 0, the output is 0. For input A equal to 1, the output is 0. Now let me write the Q3. Q3 by taking 0 as input, what is the next state? Q3. Q3 by taking 1 as input, what is the next state? Q0. So it's Q0. Q3 produces output as 0. So here it will produce 0. Here it will produce 0. So now here you see, here this is the equivalent Mealy machine for the given Moore machine. So I hope all of you have understood what is Mealy machine, what is Moore machine, how to convert from Mealy machine to an equivalent Moore machine, and how to convert a Moore machine to its equivalent Mealy machine.